Welcome to 1.2, Transformations of Linear and Absolute Value Functions, Part 1. The objective of this lesson is to write functions representing translations and reflections, write functions representing stretches and shrinks, and to write functions representing combinations of transformations. You can use function notation to represent transformations of graphs of functions. So we're going to talk about horizontal translations. When we're talking about horizontal translations, that means we're moving the graph left and right, okay? It moves right or left. It is a movement in the x-axis, and we note that in function notation we subtract it from the x inside the function, okay? And h cannot equal 0. If it's 0, you do not have a horizontal translation at all. So we move right. If we move right, it is a subtraction problem, so x minus h. We move left, it ends up being an addition problem because you're subtracting a negative. And you'll see that here in a little bit. It's kind of weird, okay? Vertical translations happen outside the function, the plus k, so plus some normally outside, and it moves it up and down. And it's straight up the way it says. If you plus something, it goes up. If you minus something, it goes down. All right, example 1, we're translating functions. Let f of x equals 2x plus 1. We need to write a function g whose graph is a translation 3 units down of the graph of f. So we're going to start with the function, and we're going to translate it 3 units down. Vertical translations happen outside the function. So f of x, and down is negative, so it's minus 3. So we'll subtract 3 from both sides. This part, we're going to call it g. So g of x is equal to, let's simplify the right side, 2x minus 2. Now you can check this using a graphing calculator, so let's check that. We're going to graph this using Desmos. So let's graph the original function, 2x plus 1. And then we're going to graph the second function, and we're going to look for that translation of 3 units down, 2x minus 2. And if you notice that this is 3 units moved down, so that checks out. So that was part A. Now let's look at part B. Write a function h whose graph is a translation of 2 units to the left of the graph of f. Okay, so the original graph, we're starting right back with the original graph, 2x plus 1. So what we're going to do is do 2 units left, that's a right or left. And remember, I said something about it kind of being the opposite. Left on the x-axis is towards the negatives, okay? So, but it's going to be opposite, it's going to lie to you, okay? So it's not minus 5, it's going to be plus 5. And since it's a horizontal shift, it's right and left, it's going to be inside the function. So f of x, and we're going to do plus 2. Okay, so we're going to put x plus 2 into our function. So where you see x, you're going to, instead of write x, you're going to write x plus 2. And simplify. So there you see you need to distribute 2x plus 4. And then 4 plus 1 is 5, so 2x plus 5. And we call that part, this part right here, they want us to call that h of x. So that is h of x. So let's take a look. I'm going to do there we go. And we'll add another function. So the original one is still there. It's still in red. Okay? Let's erase that mark. It's still in red, so I'm going to put in our new function, 2x plus 5. And we're looking for a right and left movement of 2 units to the left. So our red one was our original, and that's 2 units to the left. And it did move 2 units to the left. And you can check it at any 2 points. Okay, we moved all the points over 2 units. So that one works. So let's look at reflections, okay? Reflections in the x-axis. That means over the x-axis. So all your points on top gets reflected over the x-axis and becomes down below the x-axis. Or if it was below the x-axis, they get reflected up and now they're above the x-axis. Then you have reflections over the y-axis. So all the points on the right then become all the opposite direction on the left. Just like geometry, okay? Now, these two have specific things. If you have a reflection in the x-axis, you take this negative of the entire function, okay? Everything, take the negative of everything. If it's a reflection in the y-axis, it is inside the function. So let's look at an example. All right, example 1. Write a function g whose graph is a reflection in the x-axis of the graph of f. So we start off with f of x equals the absolute value of x plus 3 plus 1. Now reflecting over the x-axis, that means we take the negative of everything. So the negative lives on the outside. So take the negative of everything. Distribute the negative. So you need to distribute the negative. The negative stays out in front of the absolute value marks because you can't distribute it inside the absolute, so it just stays there. And then you distribute to the plus 1 becomes negative 1. And the negative f of x on the left-hand side over here, this becomes, they want us to call it g of x. So there's the equation for g of x. Let's graph it. Let's graph the original and the new. And there's an absolute value on Desmos, so that kind of helps. So the original is x, the absolute value of x plus 3 plus 1. And so there's the original, okay? Now we're expecting this to reflect over the x-axis. So we expect this to be pointed V-shaped down and it's be a reflection. So let's take a look and see if that happens. Negative absolute value of x plus 3 minus 1. And we notice that it is reflected. So we see it visually. We did the algebra right, so we're good to go. It's a good way to check. So that was part A. Let's look at part B. Again, they want us to take, write a function h whose graph is a reflection over the y-axis. So of the graph of f, so the original function. So if you look back at the notes on the previous, up higher on the previous section, the negative on vertical reflections is inside the function, okay? So that is f of negative x. So we're going to plug in negative x inside our function. So everywhere you see an x, you're going to replace it with negative x. And everything else stays the same. This is called h of x. So there is our new function. So let's graph that. I'm going to you hit the little circle beside the equation that you just wrote, it doesn't graph it. So we don't need that one, we need the new one. But the original one is still there, f is still there, it's the red function. We have the absolute value of negative x plus 3 on the outside. Oh, plus 1, I messed that up. hold on. That was 1. I don't know what I did there. So and see, I caught my mistake because I graphed it. So now, is it a reflection over the y-axis? It absolutely is, and we can definitely see that.